So in the last video, we got the Bluetooth devices to be discovered and we got the addresses of them, which is a great start. We also read up in the documentation that what we're clearly after, or what we're hoping for with these Bluetooth devices, is that they will expose a GATT service and that those services have a specific profile ID. So the hunt in this video is to try and extract that information from Bluetooth devices and effectively figure out which one is a glucose provider, that's going to provide glucose readings. So that's the aim of this video. So I'm just going to carry on where I left off with the same Microsoft documentation that we were on. Hunt for some details about where we go now we have a discovery and advertisement, and how we drag any more information out of that and continue to enhance this model. So let's just jump straight into coding. So the first step now to continue with this is to look at these services. And the thing I found and noticed is that there's one specific, this GATT service for glucose. So my presumption is simply that this service, this glucose service, is what the Contour Bluetooth reader will provide. Now, I've no idea, but it makes it really obvious that it should be, because it's a Bluetooth low energy device and there's a specification provided for how to provide glucose readings. So I'm really hoping that's what we'll find. So the key that I want to see is I want to try and extract this assigned number somewhere in the Bluetooth information so that we can see what services the Bluetooth devices provide. And then we'll also make a map to visibly be able to output what type of device it is. So the first step to that is let's make a class that can hold this information. So name, uniform, type identifier, assigned number, and specification. So if we jump to the desktop Windows app Bluetooth, because this is the Windows implementation, and we will add a new class, and we'll call this GATT service for now. And again, I kind of want to stress here that don't put too much thought into where you place things for now and what folders and what structure and what architecture. Just get coding. We can clean this up and move things around later. There's no hard requirement here to try and over-specify and overthink things at this early stage. So this will be details about a specific GATT service. And then we'll leave a reference to that website as well. So we just get that website address. I think it's always good to leave notes in the XML comments that will be exposed to developers so they can also further see where this information come from. It's an important part of the development. We're going to make this a value object again, just storing the information. And then this is what we'll expose to anyone that's consuming this. Uniform type identifier. I'll comment these in a second. So this number here has got a hexadecimal, 4 digits in hexadecimal is a 16-bit number. So if we were to open the calculator, say, go to programmer, and in hex here, put 4Fs, the largest value, you can see in binary here, it makes up 16 bits. So it's a 16-bit number. In C#, a 16-bit number is a U short. Well, it's a short, but a U short means unsigned because we don't want this number to be in the negatives. It's always a whole number. Otherwise, you'd only have half the possible numbers. So this will be a U short. And it's called assigned number. And the last one is a specification. Now, we can find more information about this in here somewhere. If we look for specifications, I'm sure. Protocol specifications, maybe. And we're looking for what these values mean. So not them, but it will be in here somewhere. But I'm not too bothered about any more information about that specification yet, because we're not using it. But considering it's in this chart, I want to include it. So I'm just going to put a string in for now, so at least we have something, and we can always update this in the future. And then if anybody consuming this is actually interested in it, they could extrapolate that from the string at least. It gives them something to work with. So this is the human readable name for the service. This is the uniform, as it says, basically. Identifier. Identifier. It's too early in the morning for typing these kind of words. unique to this service. This is the 16-bit assigned number for this service, and this is the the information we're really interested in. This is the key piece. The Bluetooth GATT service UUID contains this, I believe. That's the other thing we'll have to figure out as well, is where this is, but it's called a UUID, and I've seen it passed around as UUID, so it should have this number, but the UUID seems a lot longer than this, so we'll just have to see when we get into it, and I'm pretty sure it does contain this number though. The type of specification that this service is. And then let's just see if I can find this to reference it here. So if they want more information, they can find it. GATT Services, specifications we're after. There we go. So here's the page profile specification. So it's a profile specification, and you can see the GSS that we saw, GATT specific supplement. So this is the place we want to reference it, and we also want to call it profile specification because that's clearly what it's defined as. So profile specification. So I think that does us for our class. Now we want to provide all these options. So we want to provide, we go back to where we were, we want to be able to filter by these and extract, from, if we find this ID, we want to be able to extract from that a human readable, description of the service. So we want to make this list. So we make another class in here. Come on, brain, you're slow this morning. We'll call this GATT Service IDs. And again, there's a million ways to do this. I'm not going to overthink it for now. I'll just make this implement a read-only collection again of GATT Services. And control dot and implement the interface. Public properties. Then we need an underlying list for this. So we will have, where shall we put it? Put it at the top here. I think we'll just store a collection. Private members. And this will be read-only again. A read-only collection, so it's the same type of GATT services called collection. The backing store for the list of services. And then we can have a constructor which news up the collection. In fact, we can actually construct it all here. So let's just do a new list of GATT services. And in there, we can do the new array, which then is a new GATT service. We didn't put the constructor in here. So we should wrap these now as well. Oh, public region. I'm definitely not with it this morning. Public properties. Sunday morning coding for you. It doesn't help that I've also changed keyboards recently as well. I keep changing keyboards too frequently. This we need name, uniform identifier, assigned number, and profile specification. Assigned uniform identifier was next. U short assigned number. Specification. Put that in again. Actually, that's fine for now. name equals name. Might as well call that profile. Call it the right thing. Constructor done. Now in here we could create a new one, name ID OX 1800 and GSS, say. So that would construct our, I'm just doing this as a test for now, but this will be our constructor. And then we will just make this a static list for now. Because it's on here and it's a defined spec, and it doesn't look like it changes that often, I'm going to just simply have this as a static class that provides that for now, and if it updates, we update the class. I don't think there's any need for anything more complicated than that. As public property can now call the collection count, total number of items in the list, or in the collection in this case. Default constructor creates that list, and then this is I read only collection methods. And we need these to obviously implement all the interfaces to allow us to override the read-only collection. Now in here, get enumerator. We don't have an enumerator actually. Oh yeah, we do. We're using an I read only collection behind the scenes. It's just in the constructor we're using a list. So do the mCollection.get enumerator, just pass it down. Same with this, just pass it down. Now there is a way. Does this have no comments on there. You wouldn't see them anyway. Ignore that then. Get the underlying enumerator of the collection. Same thing. It's just for the generic class and the non-generic class. So that's all implemented. We are missing something somewhere. What is it complaining about? Have I got a region I didn't close? Oh yeah, constructor. There we go. So we have now the implementation. We have it here. So now we want to fill this list with this information. So an easy trick, I've known this since I was about 12, and I don't know whether anybody else does this, but I think it's a cool little trick. If you've got something where you want a bunch of information, but you want to inject it here, 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 and here, like kind of segregate it, and this is a table, you can either have Office installed, Microsoft Office, because you want Excel, or if you don't have the money, you can use LibreOffice. So if you install LibreOffice, it's free, and you can open up either LibreOffice Calc, or you can open up Excel. So here's LibreOffice Calc. Go to the grid, copy and paste all of these, go into the spreadsheet and paste them, and we don't need the top row, delete that. Now in here, that doesn't matter about the formatting for now. In here, you've got to think of this as if you copy and paste this now to Notepad, then you would get here, it's hard to see between, but these are tabs. So we can replace and search for tabs because the information doesn't typically have tabs anywhere. So we can use that as a find and replace all shortly, which you'll see what I'm going to do. So the idea here is to insert before on each of them where we want to, inject text between them. And now at the start here, if we go to this is the string we want. If we paste it in here, and now we delete up to where we want the name going, there, then that's the name. And then after, we delete up to that side of the name, and it go up to here, and the next bit's the ID. So then delete that. So you end up with that. And then in between here, after the ID, you would have that text. And then at this point, you would have the code, which is what we've got. So you delete that bit there. And then after that code, you just have a comma up to there. And then that's the specification. And then finally, the last bit is right after the spec, we have the closing bracket. And we also have we'd have a comma at the end of the line because we're going to new line all these. So that's what you'd have. Now, all you've got to do is copy and paste this for every item in this list. And the same for that. Do it for each column. Now, select all of it, copy, go to a notepad, paste it in, turn off word wrap, and you can see now we have effectively a big list of what looks like the correct code to insert, but with a bunch of tabs between every column. So all you do is highlight a tab, Control and H, it will then already put in the tab in the find what, and then the replace, just leave it blank, replace all, and bingo, we have a bit of code we can copy and paste into here. And if we just tab it correctly in, you can see now that should all match up with the information we need. Remove the last comma, and we now have our code injected nice and quickly and easily. So that's a little tip. I've done that for years for many things. You can use Notepad and Excel to kind of extract information and easily get it into a format you want. So let's now go to the next step in here, which is in the watcher. We will want to add one of these instances of the services. So we'll do a read-only GATT Service IDs, and we'll call this GATT Service IDs. And you might ask why I haven't made this static. It's because when we want to do dependency injection, we can easily then swap this out and construct it. And as I mentioned at the start of this project, I want to try and avoid singletons as much as possible in scenarios where you think it's just static, because it prevents you from swapping them out easily. So you're better creating a class and then turning it static through dependency injection. So this is the details about GATT services. And then in the constructor now, this watcher, in order to provide information, the full information, which is what we want, we're going to have it rely on a GATT Services ID. And this, again, obviously is hard-coded at the minute. This could eventually become an interface, and then we can do injection into that. But again, it's important to not overcomplicate this at the start. We're doing it in a way where we know we're now injecting a dependency. It's all hard-coded at the minute, and it's all not interfaces, it's actual implementations. But that doesn't matter, because it's a simple case of swapping these out for interfaces once we're ready that we need an interface, or whether we even do, whether we just keep it this way. So it's a middle ground of, not overthinking, but also structuring it correctly, that now this class depends on this service, but we're going to just construct that manually for now. But it gives us that good middle ground, so we don't have to do too much work at the start. And if it turns out this doesn't work, we need to change stuff, we haven't wasted time in the architecture. So this is just going to be a null check. A good way to do a null check, if you don't want this to be nullable, C#8 is going to start handling this for you and realizing that anything that could be null in this case shouldn't be null unless explicitly specified with a question mark. But because C#8 isn't out for a few weeks yet, the .NET 3 and C#8 official kind of support in Visual Studio, we're going to do this the old-fashioned way, if you will. So to do like a quick null check is to simply set the value of the thing that you want to say. It's if this is null, throw, otherwise set the value to this. So you can streamline it in this expression, and you can do the service IDs, the backing store of this, the private property here, is equal to the thing passed in. And this double question mark basically means if this is null, then do the other side of this argument. So if it's null, we're going to do this, which is just a throw new argument null exception and the name of the GATT IDs. So in then one line, it's a null check guard. I also want to make sure I've got this spell checking installed, because I always forget to install that when I change computers and things. Online. Spell check, I know, so I don't even have it installed. So let's get that installed. Let's quickly just restart this. And you can see now with the spell checker installed already, and it looks like it's changed the font on this as well. That font's gone a lot sharper all of a sudden. Anyway, you can see the Bluetooth here is we can either change it to the correct spelling, which isn't in there, or add it to dictionary. Now, because developers usually are lazy and just type it this way, I'm normally a fan of doing it correctly, but this is an instance where Bluetooth is always spelled like this in code. So we can add it to dictionary, or instead, we can add to our main project, I believe, the solution I'm hoping. If not, you can add it to specifics. Yeah, you're going to have to add it to a project, aren't we? So if we add it to... oh no, that is start a project. We add it to the app here, right-click on the Windows project, and add, and then spell check a configuration file. We can now go to ignored words, and basically ignore incorrectly spelt words, click add, and then this won't normally update until you open and reopen this file. So if we close that file down, reopen the watcher, it should have corrected that. So I've got Visual Studio Spell Checker now installed from extensions to make sure we're not misspelling. I did that because, oh, and I didn't even notice that there. I did that because as I was typing guard, I always forget whether guard is like that or like that. And then when you write it, you can obviously tell visually that that one's right. But when you do spell it right and you haven't got spell checker telling you, I question myself when I look at that word. So that kind of prompted me to make sure I'd got spell checking installed. So we now have the ability to now look up services, details about services to be able to extract the name. That's what we want. The current code basically gets an advertisement. We've extracted everything we can from this advertisement. We've managed to get the device name, the address, and the broadcast information. That's all we can get. So if we go back to the documentation where we were before in this client, we looked at advertisement, which is what we've now done and implemented. So I'm happy that we've done that. The next thing is client, which is us. And if we read through this, you can see query for nearby devices. It mentions there's two ways, a device watcher or an advertisement watcher. The second method is discussed in advertisement, which is that article we went over in the last video. So it won't be discussed here. But they're going to go over the device watcher way of doing it, which we could do, but we've done the advertisement way now anyway, so we don't matter. So we've done this bit already. And then this is what we now want to get to, connecting to the device. We want to start dragging information out. So once the desired device is discovered, use the device information.id, which we don't have. We've got an address, but hopefully we can use that to get the Bluetooth LE device object for the device in question. So this is what we want to start doing, getting the Bluetooth LE device. Then enumerating supported services. Well, we know we're after a GATT service, so I'm hoping that will be the information we need. It looks fairly straightforward. So let's just jump into that and start writing. I think we'll move this into a function, into a method first to make sure we keep this clean so we can easily see the difference between what we've got and what we're now going to get. So in here, let's just chuck a new method in here. And it's got to be async because I've spotted here they're awaiting. Oh, and I've just had a thought. This is UWP, so this async is going to be fun. Yeah, you'll see in a minute. Private async task control dot to pop up the suggestion, and we want we want to still use our DNA Bluetooth LE device, which we will have to update likely to add more information to, because we'll have more information in this. So we'll update that after. But that's the information we want to return. Get Bluetooth LE device It's got suggestions, that's cool. Get DNA Bluetooth LE device async. Get Bluetooth LE device, that's quite cool. That new name suggestion. In here, we don't know what we want yet. We don't know what we can get, and we don't know what we want. So we'll just start with that. So get Bluetooth device info. And we can comment this. Gets more, in fact, connects to the BLE device and extracts more information from the, and then in this case, it will be, if you go to the actual Bluetooth LE device class itself, this is the class that we should hopefully be querying, and we should have, this amount of info in here. So that will be where they get the info from. In here, var device equals, and then what was it? Bluetooth LE device, so directly .from ID. So let's see if straight away we're going to need to provide the address, which was, where is it? In here. We get the device, and it's in the args, I believe, isn't it? Args.Bluetooth address. So this is the info we want. That is a ulong. So we want to provide ulong address parameter, the Bluetooth address of the device to connect to. So let's call that. Let's just start at the top here, so where we got the device. We can now do var device equals new DNA Bluetooth. No, what am I doing? Not new. Await get Bluetooth device args.Bluetooth address, and that is it for now. This now wants to be a void async because it's an event listener. It will also want to be ending with the word async now, so it knows that it's asynchronous. Get Bluetooth LE device info. This will then hopefully replace some or quite a bit of this. So let's just go down, and in here now we want to get the more info. So that will be awaiting the Bluetooth LE device, control dot to use the namespace, and it was get, oh dear, was that the right device? Bluetooth LE device dot, oh, from async, I thought it was get. So dot from Bluetooth address from, there we go. So from ID is what they're using. There's one for Bluetooth address. So they probably put that in because there's two ways to discover. And pass the address in. And yes, this is the thing I feel is going to be fun. Yep. So one thing with UWP is that it returns these async operations. So if we F12 into this, you'll see it's returning this async operation. Now I've dealt with this before. It's not directly, you can't just await it in C#, and the reason being is because the way UWP works, it spans across like Xboxes and other things that, and other languages specifically as well. It doesn't necessarily mean the way that we use await in C# and on Windows is the same for all platforms. So they abstracted it out away to this async operation that allows you to handle a result and get a await from here, basically a task. So I'm not going to bother digging into that for now. I think that's just wasted for this video. I'll just show you how to solve this by making an actual class for it. And really, this is a core feature that I will probably bake in fact, I will put in Blueberry Core, but I'll probably move it into DNA Framework when I can be bothered. So for now, let's just add a class to Core, because this is going to allow us to use, I know it's Windows specific. In fact, yeah, thinking about it, it's Windows specific, UWP specific. Let's just chuck it in the actual Windows. I don't know, because then, no, let's move it into Core, because I'm saying it's UWP specific. The async operation is in .NET Core, so it could well be used in future elsewhere. So now I'm going to leave it in Core still. So it's just add a class for now. And again, I'll move this to DNA, but this will just be async operation extensions. Yes, because I'm going to do like a dot as task to convert it to a task. So see if I can remember this off the top of my head now. We will want a static class for one, because this is an extensions class. Provides helper methods for the async operation. And of course, I'm going to have to just quickly do something to bring that namespace in. Control dot. Oh, no, it is specific to UWP. So we want to move this class out of here. It's actually in the WinMD. I thought it was in .NET Core. So copy that, delete that, add it very specifically then to here for now. Screw it, let's just put it in here. Add class, async operation extensions. Paste that class in there. Is async operation shown in here? There we go. So provides helper methods for the async operation. And in here we want one helper, which is public static, a task that returns the result that we're after. Control dot on here. And I believe this is actually baked in somewhere in some library already because it's so common, but it's that easy to make. I'm just going to quickly type it. I can't be bothered to try and Google it and find it. So the idea is to convert the async operation into a normal task, so we can then just do .asTask and await that as normal. So to make it an extension method, we pass in an async operation that expects the result. So now we've used generics to pass that back to the result, and effectively we're going to take in an async operation of tResult, which is what we're getting given by this from Bluetooth address. You can see there, async operation of Bluetooth Ali device. We want it to return, instead of async operation of result, you want it to return a task of result, hence the name as task. So that's all we're trying to do here. The input is the operation. And very simple. Again, I think I've explained this in my threads or tasks video using a task completion source. It's a really easy way to convert non-tasky stuff into tasky stuff, is the technical definition for that. So we'll create a new task completion source, and again, keep passing down this result so that the task is returning a result. Create task completion result. Then we want to do hook into the operations completed event, and no point breaking out into a function. We will just, is this a funny type as well? Come on, tell me what it is. Oh. Async operation handled. It's a delegate, so we're going to have to drop down to a delegate directly. Right, so the completed, when the operation is completed, and I know this from previously working with Xbox code, that the way that the async operation works is that even if by the point of view hooking into this completed event, the operation was already complete, when you hook in, it will fire the completed event for you. It will always ensure that this is fired, even if you hook into the event afterwards. And that's due to, issues like this with people trying to consume it. So they've already handled that for us. So all we need to do here is switch on the operation status, and we have completed, error, cancelled. So on completed, we will do task completion source dot try set result, just in case it fires twice, and operation dot get results, because we need to return the actual info. So that will return the information from the operation that's complete, and effectively set it to the task completion source's task result, and then make sure to break. Yep. And then the next one is error we can handle. And for error, we can set the error on the task again. Try set exception. And operation dot is an exception, and error code is an exception in this case. That's a weird naming convention. So there's the exception. When operation is complete, if successful, return, or rather set result. If exception, set exception. Is there anything else we can do? You can cancel, can't you, as well? Has it got a cancel? Yep. And then started, we do nothing with. So cancelled, we want to set the task to, what is it? Set cancelled. There we go. And that's all we do there. If the operation cancelled, well, we haven't written that for the rest of it. If cancelled, set task as cancelled. I always want to put two L's in cancelled. And then finally, all you have to do here is return the task completion source is task. And then we can await that task. And that task, as soon as you do here, you'll create a new task, you'll return it. So then the await operation can now go off and do other things. And then this delegate hookback, whenever it completes, it will then update the task and set the results. Then the await will fire off, jump back in. All good task stuff, nice and easy. If you watch my task videos, you should understand that. If not, then copy and paste and ignore. Return the task. This will convert an async operation of tResult into a task of, oh, I had a suggestion there already, task of tResult. The type of result expected, the async operation. And it doesn't like the word async, so let's add that to our spell checker files. Although I do say I don't like to shorthand things, but because this is async operation, I think that's fine. Close and reopen that to make sure the spell checker is fine now. There we go. So this is our extension method, and it's in the class that we're using it for, so that's fine for now. And I forgot where we were. Watcher, was it? Here. So now we should be able to do, instead of just from Bluetooth address, because it's returning the async operation, we should have a dot as task now. There we go. Hey, that works. So now we can await it and get the result. What's next? I think we just start with looking at that information, maybe doing something with it. So let's just put a breakpoint. Oh, we're gonna have to return something for now. Just return null for now. And breakpoint here. In fact, that null. Then let's just return here for now, so we don't carry on. I just want to run this and see if this even works. And we have compile errors. There's no argument for that. Yeah, because now we rely on that services. This is where I mentioned we're making this rely on the services, and for now we can just make a new one. And then in future, when we want to dependency inject this, this moves up to the composition root and it's handled nicely. So started listening. We have device. Can we add this to a watch? Add watch and expand. So we have a device here connected. Is connection status disconnected? There's that name again. I think it's my light switch. GATT Services is what we want. It's a COM object, hence why I'm guessing then we have to, if we move down, we have to enumerate them like this, because this will then convert the COM objects into C# classes for us to be able to extract info. So is there any info in this we can gain? I mean, we've also got a Bluetooth address, address type, appearance, no idea, Bluetooth device ID. So now it looks like we've got a proper ID, because the one thing I did notice is the address, this always changes, this Bluetooth address. I thought that was the unique name, but this changes every time you run the program. This looks like the name we want. This is an actual, there's a MAC address, if you will, and an ID. So this is definitely a unique ID. So let me just add that before we go any further, because that now really does make it unique. So in our discovered devices, let's change this from a ulong, which was the address, to a string, which is going to become that true ID. That's what I want that to be. So that's in there. And we'll just have to remember to come back to that when we get to here. Oh yeah, doing that now screws all these up. Okay, let's keep going then, because let's try and get this now returning what we want. So in fact, let me just change that back a second, just so it doesn't break everything. Let's do a little bit more checking than just that. So we've got the device here. We've got name Bluetooth. Name Bluetooth. Now we actually do get null sometimes. So even though we have an address and we've had a advertisement, scannable undirected, and the advertisement contains local name null. So I wonder when we've been doing all this handling for the local name and it being null and all the updating and checking, whether when it's got no name, this advertisement is a kind of, it's almost, I don't know, pointless thing. It's something we can't make use of. So maybe when we do that, then this get Bluetooth device doesn't crash, it actually returns null. So we need to add that handling into our code. And I think then I'm making the presumption that we can remove all this name change stuff, maybe. Or, I don't know, we could keep it in, but I've got a feeling the name changed. Sorry, not name changed. The blank name checking afterwards can be removed. So with the device here, we need a null check. So null guard. And in this case, I think if the device is null, just do nothing. We can't do anything with it. So we just return. So get the info, return. If we can't do anything with it, then the, let's go back down to here. We also need that check in here. So if device equals null, return null, null guard. Now let's get the name. We want to try and get all the information we had before. And we saw that in here, it's called name. Now the GET services, let's just go for it. Let's try and get this GATT rather than not get, the GATT services. We want to try and do this service, GET services async from the device, check the communication status. So let's start with that. Get GATT services that are available. That will be var GATT equals await device dot get GATT services async dot as task to convert it to an awaitable task for us. There we go. Then if we have any services, if GATT.status is successful, remove all that, control dot, and import the namespace. So if it's successful, then we want to loop each GATT service. So for each var service in GATT.services now that we have. So all it's done is converted effectively the COM object inside the device. So the device has services, but they are a COM object. I'm wondering whether we can just use that as opposed to GET services and then awaiting it. But anyway, we've done the GET services and then the GET GATT services. That returns then a list of services. Yeah, we might try and swap that out in a minute, but I'm wondering whether by doing the GET services, it's checking the status, whereas maybe this one just is empty if there are no ones. That's interesting, actually. We should compare that. So let's see if we get info here. And let's also do var test equals device.GATT services. Let's just extract them into a test object we can monitor. And then here we get some services. So let's put a breakpoint. Here, let's just return null for now. Run this code. And that's actually complaining. I just noticed here, what's that moaning about? Got a green squiggly, don't know what the green squiggly means. Oh, is it just because we're not consuming it? So yeah, I see. The GATT services is a COM object, whereas in here, oh, it's still a COM object. Okay. So it's allowing us to just consume the services. So we're going to have to dispose of this, I presume. This device, I'm guessing it's disposable. Here, yep, are disposable to make sure all the COM objects are cleaned up. So we need to remember to dispose this service. And it does look like the services then can be just let me just for each this one as well. Just wondering whether we can cut this one step out and whether they both enumerate the same. So we should check. Let's just run that quickly. We have the device named SD Premix, which is my audio recording stuff. It's not gone in any of these, so it's not hit this loop. But this one has hit. So no, you can't just use GATT services because it's empty. So that's that. So let's keep doing this way. We get that, we get the services, and now inside each service, let's see what we have. We have a service dot device, which is the original device we've called, device ID, UUID. Is that the GATT profile information we're after? Var GATT profile ID equals service ID. Let us see. Run that again. There we go. So what is this? A GUID. Yeah, it's a GUID. Well, the service ID is only 16 bits. A GUID is a lot more. So this is, in fact, I think I've just seen that actually. Yeah, at the start there. Well, at the specific part. So I wonder if that's the bit we're after. I'm pretty sure it will be. That the UUID has got all these other things, but that looks like the piece we're after. So let's see if we get any others. 1800, 1800, 1801. Okay, what are these? So 1800 generic access, that kind of makes sense. 1801, 1801 generic attribute. Okay, so all generic stuff at the minute, but that's looking like the info we want. 1801, 1801. Just see if we can find a few others, any other different numbers to. Whoa. Okay, that one would be B1C3. That's definitely not a thing we know. That's the SD premix. So I'm guessing that B1C3 might be something, but it might be, custom, like their own implementation, hence why they don't have a number maybe. So we also have to make sure we handle when there are no known implementations. Let's see if we can find any other known implementations though. 18OA, we just skipped over it. So what's 18OA? 18OA, device information. Yeah, so I'm pretty sure that's what we need. So now the trick is to filter from a GUID to a UUID, or rather from the UUID's GUID into a GATT service ID. So like in this case, it's this, this chunk here. So we can do a bit shift operator to find that, or we can handle the, this could handle checking, against that. But because we might swap this out, or this might be a different implementation, we either want a helper function, or we want to actually extract that ourselves and provide it in here. I think would make more sense. So we want to update this class, and we want to provide that device ID. See what else there was as well, because we had some other information. We had, in fact, let's just breakpoint on it again and just inspect. So in this device here, we have a device ID, which we definitely want. So we want the device ID, The address we've already got, but we could reuse it, but we passed it in anyway, which matches, yeah. So, but we can use either. So we got the address. We want to keep the device ID. The connection status, I think we'll have, see whether it's connected. Device information. ID is the repeat. Pairing, that'll be important. Can pair and is paired. Okay, that's cool. So let's extract can pair and is paired as well. And I think that's it, and then provide all the information we had. So let's just add that to our class now. So in here, let's add a Boolean for connected. Oh, get indicates if we are connected to this device. We have the Boolean for can pair. Indicates if this device supports pairing. And we had a Boolean for paired. Indicates if we are currently paired to this device. I'm not sure what the difference between connected and paired will be. But maybe paired is like when you've associated with it once and you know that, you've approved the connection, but then it's like, say you connect to the Bluetooth device, you are connected and paired. Then when you turn the Bluetooth device off, you're still paired with it because you made that original, connection. You turn them back on, you don't have to repair, but you're not connected because it's offline. That's my presumption. And then the other one was the device ID, which I think was just a string. Yeah. So device ID, and this is the true unique ID, I believe. The permanent unique ID of this device. And now we also want, it's got a bunch of services. So we need to provide a list of services. And what information do we want in them services though? We have, in fact, let's breakpoint once more and let's have a look in the services down here. That'll we need another class, and then we'll fill it with this information as well. So let's just have a look at, not quick watch. So the service has the device that we know about, the device access information, allowed, parent services, don't care about UUID. So there isn't anything to really extract from here other than the unique ID. Is there any more information we can gather from that? So we've got that. Now what? Perform read-write operations on the characteristics. Okay, well, I don't want to keep going too far into this because we're doing quite a bit of code change here. Let's try and focus on this stage. So let's just for now, if extract, in fact, I'll leave it there. What I'm going to do is move that over to the next set once we do this. We know now this ID contains the GATT service, what did we call it? The GATT service assigned number, or GATT profile assigned number we want to do. Get more info and connect. So I'm going to leave that bit here for now because that I think is going to go down a further rabbit hole, and we're already doing quite a bit of change. Let's just clean this up now, return the new object and clean all this back up. And then in here we can have, we will then need a list of services, and those services will then contain information like that ID and the human readable name and stuff like that. This will now need to be updated in here. We will also need to update all of the parameters with comments. We need to now pass in connected, can paired, connected, can pair, is paired, and device ID. And now in here, let's just redo that comment. Add all the comments. Bluetooth device address, the device name, signal strength, the broadcast time of the, I don't know if that's important now. Yeah, let's keep it in there. Discovery. If connected to the device, if we can pair to the device, if we are paired to the device, the unique ID of the device. That's the new constructor, new information, also set the new information, and connected equals connected, can pair equals can pair, is paired. Why is it not? Oh, call it paired. And device ID equals device ID. So we set them up, toString. Now in here, we have the name or no name, and we have the Bluetooth address, signal strength, and we could also add, did we get anything else? Connected. We could have a star in the name of we're connected, or paired, or device, unique device ID. Let's just chuck in the, I don't think that address is valid. Let's just change that for device ID now because that's more unique. So let's just do that for now, actually, in the toString. So I'm happy with that. That's got everything it needs now. Let's change this now. We're planning on getting this fully done. Let's go back before I forget. Change this to a string so we use that new device unique name as part of the discovered devices. So that's how we handle the uniqueness of them. That's done. In here, clean time, we'll get device. We need to return the device first so we can come back to this and actually finish that bit off. So I think with that, we don't even need, don't need the name like that. We can just grab it at the end. GATT Services will loop through and do more after. So here, really, we just want to return the new device. It's in a constructor, rather. And then in here, we now want to do device ID is device.device ID. Address is device.address, Bluetooth address. What's that complaining about? Named argument declared out of possession. Oh yes, because we haven't finished yet. We've got the name is device.name. We have broadcast time, which I haven't seen in here. That will be on the advertisement packet. So, and also the signal strength. So we actually need to pass in, as well as the address, date time offset, broadcast time, and short for the RSSI. The time the broadcast message was received, the signal strength in dB. Go back up to here, pass in the args.broadcast timestamp, yep, and args.raw signal strength. That's now passed in. We can now pass that on. Broadcast time, RSSI as RSSI. Let's also comment these. Device ID, Bluetooth address, device name, broadcast time, signal strength. What's left? Connected, was it? is device dot connection status equals connected. Can pair was device dot pairing. No, device dot information, was it? Access information. Nope. Device information, that was it, I think. Pairing, there we go. Can pair. So is connected. Can pair is paired. Oh, it's going to be easy to pair. We just do pair. That'll be easy for the next step then, looking at it. Pretty much just call a function by the looks of it. Not sure where you'd pass in the pairing IDs and stuff though to accept it, but we'll find that out. Anyway, what was I doing? Is paired. I think that was it. And yes, that's all the information now. Return the new device information. Then in here, we can now add, once we've enumerated these services, we can now, this device information will also contain a list of supported services. Then we can finally filter that list by glucose specific Bluetooth devices. Then we can try and connect the device. And then it'll get really fun because then we can actually pull the glucose information out of the actual device. So we're not far off now on that. Right, last but not least then is to clean up this function. So we've now got the new info. We've done a null check. So now let's handle this. So a new discovery now is, this also needs locking because we're looping this list actually. So let's just false that, lock thread lock, because we are checking inside the list that could be changed. New discovery equals, and this now, discovered devices, the key is now in the device, and we're going to start using the device ID. So that's what we're going to start. Lock your doors. Check if we new discovery. Check if this is a new discovery. And it will be if we don't contain a device ID. Name changed. Right then, so what's changed here now? If it already exists, which is the same, it's not a blank name. Now, we're not using args again. We shouldn't use args past this point because we've got the new device. So we want the device.name. And the name is different. So now we need to lock this because we need to now get the discovered device. Yeah, we need the existing one. So actually, var existing name equals a default string, existing name equals, or if not new discovery, existing name equals discovered devices, device.deviceID.name. If this is not new, store the old name. Now we've got existing name we can have, and this would also not have been thread safe here. So this is also not thread safe. It's very easy to break thread safety without realizing. So that's actually another thread issue there that we had. And if the name's different, so if the existing name is not the same as device.name, so I believe that's now correct. What next? So here we lock, we get the name. We do if the device is new, and we already have a device. Now I don't think this blank check's needed now because we haven't seen any come through with a blank name when you query the device now properly. So I don't think that's needed. Get the name and create the device we do above at the very start. and add and update the device is about the only thing left, I think, there. This will be the device ID, and it equals the new device. And then all the other events fire. So I think that's it. That's the new code in there. Just seems weird because we just cleaned it up and it's done. I feel like I haven't really tested or I've missed something. So let's just run this and see. There we go now. So you got now a new device with the proper unique name and the signal strength. And there's another one. And there's my phone. Everybody knows what type of phone I use at the minute now. I think I'll put that in square brackets, the ID, so it doesn't look as jumbled together there. Come on, brain, work. Where are we? We are in device, in string, the name. Now I think I'm going to remove this. No, let's leave the no name in, but if I'm going to do query strings around it, it's going to, well, yeah, it is what it is. Let's just put the same thing around there. Oops. And let's run that. So it should be a little bit clearer to see the name and the unique ID separately. There we go. Now let me just get the Contour app now. And there's a point. Let's put a breakpoint on the device because we're positive we've seen this. So if, yeah, in that case, let me just see. Let's just do an easy check. If service.uuid, yeah, that was a really nasty way of doing this. Dot to string n, which I think is just the GUID. You'll see what I'm trying to do in a minute. So we get the info, get a string like that. So it's 1, 2, 3, 4, and then the next 4. So it's a substring. I'm just going to do a really nasty check just to see if this is what we're hoping it is. So substring start at 4, length of 4 equals. What is the glucose one? Glucose is 1808. So if it equals 1808, then debugger break in. Now I'm just doing this to see if now when I turn on this glucose monitor, this Contour glucose monitor, if it will have the service ID of a glucose monitor, which I'm hoping. So I'll just turn it on, hold it down for another few seconds to flash blue. Right, so it's flashing blue now. We probably won't see it output here because as soon as it does, if it has got that service, will break into code. Oh yeah, there we go. So service ID 1808, and I'm guessing this device name is hopefully the Contour. Yeah, there we go, perfect. So that's a really good sign. We actually know that one of the services that this supports is that glucose reading. So that's really good. It's now beeped off. I don't know if it's going to be discoverable again now, but that's what we've seen. So let's just see if it shows up in here as a Contour device again. There we go. Yeah, so that's the device, and we know now one of the services it provides is the glucose service. So I'll leave that in there in case you guys want to test that. And I think we are good to commit this code. So let's just jump over to Get Cracking. And in here, stage all, open up, expand all. Let's take a look at what we've done. So we've added the new thing there, that's fine. We've added this helper function to the Bluetooth for now, all commented and sorted. We've added the spell checker file. We've changed the IDs to now the unique name. We've passed in the services. We've created them and done a null check. We've now changed this code here to create the device information in a new call instead of being inside the advertisement received call directly. We null check it and do nothing if we don't have it. If we do have it, we get the existing name and if it was discovered. Check if the name was changed by basically just changing the arguments to the device names. That's simple. And then we add the device at that point or update it if it exists. And then that code now is moved out. This is the key addition. We've done the get Bluetooth ally device async, so it's nice and separated into this call. It's commented. It looks fairly simple now, actually. It's taken that long to write, but it's pretty simple. So we just have to do get GATT services, or rather get from Bluetooth address to get the device, and then get GATT services to loop the services. It's only a few lines of code, and then we've been able to extract more information from this device object. And then we have our instance of this device, which now contains more information. As this grows, that will contain more and more. And we added this GATT service that we haven't used yet, but it's ready to use now, which basically provides an ability for us to now map from this code and the GUID to a nice way of showing some visual. So instead of it being nothing in the console app just showing a device, we'll be able to list a bunch of these below the device of what it supports. So that's the next plan. That's everything. So read more device information, including GATT IDs. That's that. Commit, push, and we're done. So now we have some basic information. We've managed to figure out what devices are providing what services and based on a name. I think next we want to try and filter by these and provide some kind of class on top of this raw Bluetooth class now to filter by glucose and then start actually connecting to the device and reading from the device. So we'll do that next. So feel free to leave comments and I do get back to all of them, or join the Discord chat for more conversation. And if this video was helpful to you, do please consider donating.